The last section in this chapter is over the mean value theorem for integration. Now, if you remember just for a second, it hasn't been that long since we talked about the mean value theorem for derivatives. The mean value theorem for derivatives, if we look at this exact same graph that we've got drawn right here, what we said is that if I have 2 points, well, let's use the 2 points that are on the graph. If I have A and B, and I find my average rate of change from A to B, there will be somewhere along the curve where the instant rate of change, the tangent line slope, is equal to the average rate of change, the secant line slope. So that's what the mean value theorem said for derivatives. Now here's what it says for integrals, okay? Consider a continuous function from the closed interval a to b, and we know that the integral from a to b of f of x dx is equal to f of b minus f of a by ftc. We know that that represents the area under the curve from a to b. What the mean value theorem is interested in is the value x equals c that gives the function value f of c so that the rectangle of height f of c and width b minus a will yield the same area. So if we're on a graph here, here's my x and y axis, okay? What we're trying to find is some point on the function, we'll call this c, that makes this point f of c, where that height takes and makes a rectangle that has the same area as it does under the curve. You can kind of imagine in this case that if we took this section of area that's above the curve and rotated it this way, it's going to fill in this section here and make that rectangle. So that's what we are trying to find, is the C value that gets us to the F of C value that creates a rectangle with the same area. Okay, that is the goal. So if we think about that, based on what we have, we want the integral from a to b of f of x dx, that's the curvy area, to have the same area as the rectangle with a base of b minus a and a height of f times c. That's just base times height. That's the area of a rectangle. Okay. Now, that's what the mean value theorem for integration says. That is useful, but not particularly helpful to us. What we use this to find instead is we're interested in this f of c value because that represents the average value of the function. If I were to take all of these heights, f of c, f of whatever, all of these different heights of the function, and I take the average of all of those heights, that height is going to be f of c. So that's what we're much more interested in. What's the average value of the function on that interval? And so hopefully you can see that to do that, we would just need to divide by b minus a on both sides. And that's how we get 1 over b minus a times the integral from a to b of f of x dx is equal to f of c. F of c is the average value of that function, okay? So this is what's really important when it comes to MVT for integrals. It's not so much the original wording of MVT, but this result of average value is what you're going to have to interact with the most. So we can do this in a lot of ways. We can have a function and know our fundamental theorem integration rules, or we can work graphically or analytically, just the way that we've done on previous problems. So this very last example says, find the average value of the function f below on the interval from -2 to 5. So what we want is we want 1 over 5 minus -2 times the integral from, not a, we know what this is, the integral from -2 to 5 of f of x dx. Now, we're not going to use an integration rule because we don't actually have the function f of x, but we do have this function here, f, that we can find the area under the curve. Now, if you remember from a couple sections ago, we've seen this graph before. The area of this triangle here is 9/2, and the area of this semicircle is 2 pi, half of a circle of radius 2. So the area, this value here, we're going to have 1/7 times 9/2 plus 2 pi. And so that is our average value. Now you could distribute that, you could condense it down, what you could, let's go ahead and approximate this with a decimal just so we can kind of get an idea of what we are finding. So we're going to have 1/7 times 9 divided by 2 plus 2 pi. Where's my pi button? Don't know. We'll use Okay. So I get approximately, because we're rounding, 1.540. Now, what we're saying is 1.54, that's going to be just a little bit past 1.5. We're saying that this rectangle right here has the exact same area as that triangle plus that circle. And you can kind of start to imagine how that would be true. You take this triangle here and use it to fill in this. You take this triangle here and kind of rotate it into this region. Then we've got this weird circle area that we can use to fill in these bits. And so that is exactly what the average value is finding. So what we're saying is, all those different heights of the function, all those different f of x values from -2 to 5 are going to average out to about 1.54. And so that is what the mean value theorem says. That's what the average value theorem helps us to find. And we'll see a lot more applications of this in our next unit.